Hello and welcome to our presentation of security of alerting authorities in the World Wide Web. This is a joint work with Eric, Jochen, Thomas and Matthias, and I, Puyan, is going to present to you our research on the interplay of DNS and Web PKI ecosystems in securing online emergency services. Online emergency services are part of the broader critical infrastructure, and the research shows that people are reliant on trustworthy sources during emergencies, crises and disasters, which are, of course, provided, among others, through websites and web portals of respective authorities. At the same time, it remains a challenge for users to distinguish between legitimate and malicious online services. You would say we do have protection mechanisms for that, right? To make a point, I'm going to start with an example. Here you can see the screenshot of two websites claiming to be the legitimate portal for the paycheck protection plan in one of Germany's states. As you can see, both websites look exactly the same. Both are represented under the Germany's .de namespace. Both have HTTPS enabled, so that you can see the green padlock in your browser. And a tech-savvy user could even verify that one of them, which turns out to be the fraudulent and spoof domain name, is even securely delegated. The fraudulent website managed to defraud 4,000 applicants, and the scammers remain unknown until today. So why do users trust such scamming websites and campaigns again and again? To understand that, we need to first review how the secure web-based communication is structured. Let's say that you're an authority and you want to go online. The first step is to have a domain name delegated to you. This can be under an open namespace such as .com, .org, .net, where anyone can register a name, or this can be under a restricted top-level domain name with restrictive eligibility requirements, such as .gov, which are reserved for specific types of organizations. For example, in case of .gov, only for governmental organizations in the US. The choice of domain name for an alerting authority can influence its trustworthiness and its recognizability. The next step is to obtain a certificate that can at least guarantee the domain name ownership, a domain validation certificate, or in addition can also act as a proof of identity, an organization or extended validation certificate. Finally, you would load the certificate on your web server and point your name servers to that server. On the other figurative side, the public would discover the domain name using search engines, social media, and alike, and would navigate over. Some part of this procedure remain opaque to the users. In our research, we focus on domain names and the namespaces as the starting point, which can also provide an identity hint. Say if you're under a .gov domain name, one would know that you're a governmental organization. We will also focus on DNSSEC as de facto the standard procedure to secure your domain names. Also, the certificates as proof of domain name ownership or proof of identity, depending either you're using a domain validation or an organization or extended validation certificate. In our work, our contribution can be summarized in 3 points. First, we define a threat model for web-based communication. We also introduce a method to discover and analyze alerting authorities, and we put these two steps together to analyze actual alerting authorities in the state and draw a holistic picture of their security profiles in terms of what we call assurance profiles. But first, we need to define what do we mean by secure. This is where our threat model comes into play. We define security on 3 dimensions: identification, knowing with whom you are communicating; resolution, making sure that a name has been mapped or resolved properly into the correct network service; and finally, the actual data exchange is protected from eavesdropping or from manipulation and the like. Now, the question is, how do DNS, DNSSEC, and Web PKI amount to securing online communication? I'm going to start with a couple of examples. Let's say that you want to visit cdc.gov. The .gov restricted TLD indicates that you are interacting with a governmental website. DNSSEC guarantees that your resolution is protected, and the OV certificate provided by CDC shows you exactly with whom you are communicating. So identification, resolution, and transaction are all safe and protected. We call such setting a strong assurance profile. Now let's say you have the same setting, but this time with the DV certificate instead of an OV or EV certificate. Again, the restricted TLD indicates that you're communicating with a governmental website, as it is the case here for bernco.gov, but you wouldn't know with whom exactly you're communicating since you need extra pieces of information to find that out. So we argue that identification is ambiguous, and as such, we consider this setting as having a weak assurance profile. Now let's say that you neither have DNSSEC nor you are located under a restricted TLD, such as it is the case for USPS.com, and you only provide an OV or EV certificate. Of course, resolution is susceptible for hijacking, and identification would only work if resolution succeeds properly, so that at the last step the server can provide you the OV certificate and you would know with whom you're communicating. Just like the previous setting, we call this setting also a weak assurance profile. Finally, let's say that you only provide a DV certificate without any respect for DNSSEC or restricted TLD, which is the case for the COVID fundraising website of the CDC Foundation under giveforcdc.org. In this case, you can see that the identification and resolution are insecure, and as such, we would say that this setting provides only inadequate assurance profile. If you want to have a general overview of all combinations and see the security implications and the assurance profiles, I would refer you to our paper. Now that we have our third model, now that we know the role of DNS and Web PKI ecosystems, we can move on in applying it to actual alerting authorities in the state. For that, we start our measurements with the list of alerting authorities provided by FEMA, which comprises 1,388 alerting authorities as of September 2019. We mapped these alerting authorities to 1,365 URLs, and in turn to 1,327 unique hosts. We executed our measurements from October 2019 up to March 2020 from various vantage points in Europe and in the US. So how does our analysis and results look like? Let's start with namespaces and DNSSEC. We were wondering how alerting authorities are handling dedicated domain names, how are they integrated in a global DNS namespace, and are their names properly secured using DNSSEC. We find out that about 49% of alerting authorities do not have dedicated names and as such are dependent on other entities. We also see that more than 50% of unique names are not under restricted TLDs and as such provide poor recognizability and inferior security. This is a very unfortunate fact because as an alerting authority in the States, depending on your field of operation, you would have enough alternatives among restricted namespaces such as .gov, .mil, .edu, or the well-structured .us namespace. Finally, we see that 96% of unique hosts do not support DNSSEC at all, and as such are susceptible to DNS hijacking. Moving on to Web PKI. We asked ourselves, to what extent do AAs adopt Web PKI, and how is the historic landscape of X509 certificates shaped among alerting authorities? We find out that about 15% provide none or invalid certificates and are practically insecure against identification and transaction attacks. Using the logged certificates in transparency logs, we could also investigate the historic development of certificates among alerting authorities and we found out that OV and EV certificates used to be the more popular choice among alerting authorities, and that certificate sharing is rising, which also increases faith sharing, meaning that if one shared certificate gets compromised, it's going to have negative consequences for multiple hosts. And finally, we see that established and giant certificate authorities are giving their place to free and automated DV certificate issuers, which could imply that alerting authorities care more about encryption than identification, since DV certificates do not provide any identification guarantees. Now we can use our threat model to merge the previous results into one holistic picture and qualify the security of alerting authorities in terms of assurance profiles. As you can see, only 2% provide strong assurance profile, 20% weak assurance profiles, and the remaining 78% provide inadequate assurance profiles. The main reason for the inadequate assurance profiles is lack of DNSSEC combined with DV certificates. And as I mentioned earlier, 15% either provide invalid or no certificates at all. So how can we get out of this bleak situation? If our threat model sounds sane to you, you should definitely choose a domain name under a restricted namespace, and you should go for OV or EV certificates. Of course, you should have DNSSEC enabled in any case. If OV or EV certificates are not an option for you, you should also consider alternatives to DV certificates. For example, the TLSA domain issued certificates, DNEE, which would remove the ambiguity between public keys and the certificate authorities who certify those public keys. And last but not least, you should use dedicated domain names and certificates to avoid faith sharing. If you're interested in our work, if you want to have the raw data, if you want to know more details, if you want to go through the assurance profiles of all the alerting authorities that we examined, you can check out our website under aa.secnow.net. If you have any questions, if you have critique, or if you want to work with us, you can drop me a line at pfd@acm.org.